Okay, so what I have here is I have two solid chemicals, and I'm going to mix them together. We've seen some very cool reactions so far. I don't know where this is going to fit in. Before I do so, though, I see that I definitely want to, there's some stuff here. I kind of want to just kind of wet this and clean it off here a little bit. Not sure why I'm doing that, but it just seems like I should. All right, so I'm going to put that there, some water, and I don't know. Just going to put this here. All right, now I'm going to put one solid in. All right, and I'll put another solid in. Okay, maybe. Okay. Okay, now what I'm going to do is I'm going to now stir. Okay, I'm going to stir this solid, and I'll move this back.
Why is there water there?
I just want to, I'm a clean freak, you know.
It's part of the magic trick.
All right, so I'm stirring, and what kind of observations do you make so far?
Melting. It's melting.
Solidizing?
No, it's becoming not solid. It's melting. It's becoming a liquid.
It's like,
Yeah, it's definitely getting slushy.
it's slushy.
Is something new happening?
What did you put together? I think
Something new is forming. I mean, yeah, it's hard to No, it's not fake snow.
It's real snow, Emma.
Oh my god, it's becoming liquid.
I'm gonna just gonna erase this.
Put down like cold or hot?
So clearly, we're seeing a slush. Something changed. Nah, I just put some water there. There is a physical change. Well, there is definitely a chemical change happening. Now, if I was to waft this, you could smell a little bit of ammonia. Okay. Okay, it's a new chemical. All right. So now, I know there wasn't any type of flames or like pandemonium and smoke and dancing gummy bears and all that stuff. Okay, so this is pretty much it for the reaction. I put two white chemicals together, mixed them, they became a slush. You can't.
Yeah, but you put a $20 bill and got a $1 glass. So I mean,
Well, yeah, but still, party people, this is still a cool reaction.
It doesn't have anything.
You guys are reaction snobs now. Oh, you had flame and you had $20 bills and night.
you should have started with that.
What is wrong with this reaction?
You should have started with that.
Wait, I think it's pretty cool.
We're not ungrateful.
Oh no, that's the light.
Wait,
You
who's
should have started with that.
What is so? Well, I want to know what's so wrong. Stay back, 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 stay back.
Is there anything to do with the water or no?
No, look. I'm gonna back up here. Okay, and look, so I can clearly see that you guys do not appreciate a good chemical reaction.
I just realized what you're doing.
No, I don't know. I want you to just stay by yourself. So
It's
listen.
scary.
Yes, we can see you, Tristan. Good stuff. Okay. Now, listen,
Why did you say watch out?
because this is a Christmas. Please stop.
Don't touch it.
My mistake was to have this anywhere you guys were sitting. You're up. So in any case, my bad. You're right. So yes, I see you playing something magical. Okay, now, so yeah, I'm sorry that you guys don't appreciate a good chemical reaction. What's that? Listen, it became a slush.
I can't tell.
Did something change?
I can never tell if
Would you say this was spontaneous?
No, because you had to put energy. No.
I did mix, but couldn't mixing be part of the activation energy? So could I make a case this was spontaneous?
You had to stir. You had to like keep stirring.
I just stir it. You didn't see me stop stirring, correct?
Yeah.
Okay. So cool, right?
Yeah.
Go.
There's nothing to it. That's the reaction.
Just pick it up.
All right. There's nothing to it.
Pick it up.
All right. If you look closely at it, there's something you could probably find. So if you look closely, that you could probably see that it is pretty a cool reaction. All right. So.
Why?
Oh, now we're interested. Please move on. Why am I able to pick it up? Ah. And does water at room temperature freeze?
No.
So my friends in chemistry and bio, we made the water freeze to the beaker.
Oh. That's why there was. I knew there was.
So my friends, somehow there was a chemical reaction, okay, that somehow transferred enough heat away, okay, to freeze the water. Okay? Now, if you think with me for a second, okay, in order for water to freeze, to go from a what? To go from a liquid to solid. Now, who's got more energy, liquid or solid? Liquid. Solid. So a liquid's got more degrees of freedom. Solids exist as what?
Solid.
Solids exist in perfect, usually very nice crystal lattices. So we've got a crystal lattice of water. So we went from free what? Water molecules to crystal. What happened to the entropy?
Decrease.
Okay, for the molecules. Now think with me for a second though. Also, the liquid for the solid. Now, in order for it to go from a liquid to solid, it had to release heat.
So the system decreased, but the surroundings increased, but
Well, hold on. What made the water give up its heat?
Whatever you would.
This reaction pulled the heat away. Freezing at this temperature is non-spontaneous. We don't see, if you do Fahrenheit, we're about 70 in here. If we do degrees, about 20 degrees Celsius. Water doesn't freeze at room temperature. So we had to make it happen. So this chemical, okay, forced it. This is a coupling reaction, right? This chemical forced water to give up its heat to freeze. It's a coupling. So therefore, this chemical reaction must be what?
Non-spontaneous.
It better be spontaneous. Didn't this chemical force water to freeze?
How cold is that?
Okay, you can feel how cold it is. Put your finger on the bottom.
I'm not jacked, but that's okay.
So cold. How do you get that
wait,
cold?
is that the
Yeah.
Wow, so cold.